But I think we're on track now. A couple very brief announcements. One is that Josh Leonard has changed the time of his defense on the 3rd of October from 9 o'clock to 8 o'clock. I know that's really early in the morning for a lot of us, but I encourage you to try and be there if you can. And we have added a seminar back in on the 7th of October. Mutaya, and I'm not even going to try to pronounce your last name and make horrendous mistakes. Mutaya will present on soil and water conservation research and technologies in India. He's a visiting Fulbright scholar here in the department. So I think with that, I will go ahead and introduce Pete Bauman from SDSU Extension, who's going to talk today on the distribution of undisturbed habitats in eastern South Dakota.
Thanks, John.
Thanks a lot. Look at this for a second.
Before I get started, I wanted to thank SDSU for the honorary doctorate. I'm going to go ahead and rescind that and go back to my master's. So, thanks a lot. Too much pressure. All right, thanks a lot, Josh.
Sure.
So many of you were here last year about this time when we presented this data. I want to introduce Ben Carlson over here and Tanner. Where'd Tanner go? Tanner, home right next to me. These are the two technicians that are working with me on this project day in and day out, and really what you're going to see today is a reflection of the quality of the work that these two guys have done over the last year and a half, really. So, those of you that were here last year got a little bit of a taste of this. I presented the results from the Prairie Coteau and some results from Southwest Minnesota. Fast forward a year, we've completed our work for eastern South Dakota and are now in this western South Dakota. So the way this talk is going to go today, I'm going to talk a little bit about the why we needed to do what we did, a little bit about methodology, but I'm not going to spend a lot of time on methodology because several of you have seen methodology already, and the methods are quite, it can be quite involved, not necessarily difficult, but I really wanted to focus more on results and where I think that we can go. So the handout I gave you kind of applied toward the end of the talk, and that's just a brainstorm list of where I think projects could go, and we could build many research and inventory projects off of the data I think that we've collected here. So with that, I'll get started. And I think, feel free to shoot out any questions during the talk that you like. We obviously have time for questions at the end. We got started here a little bit late, so if you got a burning question, just shout it out, and maybe it'll help me focus too on where you guys want, what it is you need to hear. I want to acknowledge our partners. There are very many. Specifically, the funding partners have been, the big funding partners have been the Nature Conservancy, South Dakota Game Fish and Park, South Dakota Natural Resources Conservation Service, and the Northern Great Plains Joint Venture. Minnesota Department of Natural Resources funded a portion of the Minnesota work. And then just a lot of tech support and partners from many people in the room. I want to specifically acknowledge Dr. Mike Wimberly here at the Geospatial Sciences Center for Excellence. Mike's hooked us up with some of the workstations and things like that, so been a good mentor through this process. The why is not really too hard to understand. We've gone through an era of land conversion since about the early 2000s, and in about 2012 things really kind of hit ahead. There's a lot of court reports that were coming out on loss of grassland. Crops were at sky high, $7 corn, and it really was the impetus to restart that conversation on conversion. Conversation's never really gone away, but the 2012 era allowed a significant opportunity to assess the impacts of Farm Bill and legislation and all those things, and high commodity prices, crop insurance, etc. So many reports came out about where we were at with land conversion. In all of those reports, the vast majority, save only a couple, relied on the NASS data, the National Ag Statistics Service data, specifically the cropland data layer. Good stuff overall. It helps us paint a broad picture of the landscape, but it was missing something for me as a land manager, ecologist, scientist, my previous career with the Nature Conservancy. I always wondered, what's the portion of that impact, that conversion, that actually was native grasslands, native rangelands, native sod? In all of that discussion, if you remember back 3 or 4 years ago, the height of discussion in the newspapers and everything channeled towards CRP. We talked about loss of grass, but it always came back to CRP. And we didn't have a very healthy discussion, I don't think, on how much native rangeland we were losing. So this is what NAS data does for us at the grand scale. The World Wildlife Fund, as an example here, has created these plow print maps. They've taken the last 2009 through 2014 of NAS data and mapped it. They've done it sequentially and they've done it cumulatively. And this is what basically has been farmed in and out over the northern plains over the last, Josh, can I get rid of this
No.
top thing?
I've never tried.
Oh, okay. I probably
But
should then.
there's, yeah.
Okay, we'll let it go. Anyway, this is the Mississippi Delta plow print, and then the Northern Great Plains plow print. Great stuff, helps us really understand what's going on at scale across the Northern Plains. Not a surprise for many of you in the room what that map might look like. When we drill it down to South Dakota, it helps us get a better idea of what's going on in South Dakota. But what NAS data does not allow is really fine detail. Conversely, this is the Nature Conservancy map of South Dakota. This is circa early 2000s of our native habitats that are left, or potentially untilled habitats. Again, the source of this map ultimately is the NAS data. Okay, if you're not familiar with that, this is why I'm making such a point on NAS data. What NAS data is pixelated satellite imagery that needs to be interpreted on color schemes. That's a very simple explanation. What happens then, because it's pixelated data, the categories on those pixels, when you start drilling into very fine detail, and by fine detail I mean even at the county level, the township level, the section level, the tract level, it starts to wash out pretty quickly. And I've kind of cut all those examples out of the talk here, but basically when you drill in at a section level, it's just a whole series of pixels, and there's many, many colors in it. And so it's an averaging of pixelated data that helps us understand what the landscape looks like. So it's great at scale, it's poor at a fine resolution. So we felt we needed something much better to look at and to determine what is the status of actually native grassland in this list, because you can't pull out, even though there's a pasture grass category, you can't pull out with any level of confidence the tracks that are actually grass. Does that make sense? So, okay. So that's not going to work. So what we then, we had some friends in certain places within FSA in South Dakota and Pheasants Forever that were using the Common Land Unit data, which is a different data set available through the Farm Service Agency. Available is I use that term very loosely. It exists. It's not very available. But we were able to work it out with the Farm Service Agency to get some pilot data. From that pilot data, we got data for South Dakota, and you'll see that later on in my talk, we now have an MOU with SDSU, the Farm Service Agency, that we have 6 states of this Common Land Unit data. What this data is not pixelated data, it's actually mapped data. It's actually true polygons drawn on a map of what the land use history is of any individual tract or any individual field. So that's a really important thing, because we can now look at it and say something does a tract, an area, a field, does or does not have a cropping history. And that's the really important other part of the Common Land Unit data, is that it tracks cropping history over time, regardless of what the current use of the land is. So if it's circa about 1950 or so, if the land was cropped even for 3 or 4 years and it was recorded as cropped, that land would continue to have that cropping history, even if it's under grassland today. Okay? And that's what we were really trying to get at, is what truly is native sod and what has a cropping history. Now there's a lot of nuances with the Common Land Unit data that I don't really have time to go into today, but that's the key point. The other thing about the Common Land Unit data is that the data is circa 1950, but we feel that it likely reflects cropping history further back, 1930s, maybe even turn of the century. If those fields were continuously cropped, you know, if the farm was established in 1890 or 1910, those fields were continuously cropped. By the 50s and by the 70s, if those fields were still being cropped, they were generally enrolled in the farm programs. And generally speaking, there's a pretty high degree of tracking of those fields. So it's a great data set. It's a starting point. Okay, so how do we determine what is native or undisturbed? We had to make a judgment call, and there's a lot of arguments for what disturbance might look like. You might say that a cowed out, grazed out, you know, pasture, prairie that's only got Kentucky bluegrass left in it is disturbed. And you can make that argument. You can maybe make that argument very well. But we had to have a more of an objective starting point. So we said iron in the ground. Does it have post-colonization, you know, settlement? Iron in the ground was kind of our starting point. Was it tilled, and was it tilled for the purposes of crop production? So what we had to do is develop this deductive assessment. You can't really look at a landscape and say what is native. Okay, you can't look at aerial imagery or anything like that and say definitively this is native grassland, this is native sod. But you can look at it and objectively say what is not native grassland. So that's what this deductive assessment allows us to do. So our first cut, we take the landscape. These guys are looking at the landscape basically a square mile at a time. And the first immediate cut is anything with a CLU crop code. It's got a cropping history. We don't question it. It's out. We throw it out. Regardless of whether it's under corn today or whether it's under CRP, it's gone from our analysis. Then we go into the landscape, and this is the heart of the work that Ben and Tanner do. It's looking for other crop ground that's not recorded, other insults, use that word, other disturbances, insults to the land, gravel pits, confined animal operation, large farms, cities, municipalities, roads, anything industrial, anything that points to the direction that there was disturbance of that sod, that it's not native anymore, all of it gets thrown out. And what we're left with is, by deductive reasoning, is likely what is left is likely the best chance that it's of the footprint of our native sod across the landscape. Now, the two pictures on the bottom, we are not making a judgment call on quality. We're only saying that it is untilled. So whether it's got much value or not is a discussion left for another day. We're basically getting us to the starting point of saying what is or is not tilled. So we're not going to go through this in detail, but this is a list of all the things that we throw out. But we've got to kind of categorize ag disturbance, residential disturbance, or industrial disturbance. And even this is never complete. We're always finding new things that show us that something is disturbed. But generally speaking, those are our categories, and those can be found in the reports. So what does it look like in the end, kind of the end? When we walk through the landscapes, what's black has a cropland history, that's thrown out immediately. Then they look at everything else that's left and determine if it should stay or go. And everything else here that you can see, whether it's a farm or a gravel pit or planted tree belts, feeding operation there, whatever it may be, is thrown out. And what's left, you can see is shaded green. That's what's left to say that's likely the native, undisturbed land in that section of land. Okay, that's basically the process. It does get a little more complicated than that, but that's basically the process. Now this common land unit, I've been talking it up, and it's kind of the holy grail, but it's not perfect. And what goes on here, what can happen is, first of all, we have to understand that it was never intended to be a conservation tool. It's a practical tool for tracking cropland use and cropland footprint. So what can happen is that something might have been designated as cropland in the past, but it can be redesignated as non-crop if it's being used for something that's permanently going to be non-crop. For instance, this list on the left here. A housing development likely is never going to go back into a cornfield. So therefore they would take the crop designation off and put it into a non-crop designation. Makes sense. This doesn't really cause us any trouble because we can see these things. It doesn't matter if they're crop or non-crop. If it doesn't get thrown out right away, Ben and Tanner easily see those things and they throw them out from the analysis. What's not so clear though is this one. We didn't see this one coming initially a year ago, was protected lands, or lands that are under some kind of conservation program, whether they're owned by game fish and parks, maybe they've got a U.S. Fish and Wildlife Service easement on them, maybe there's some other public land, and it's very inconsistent, but once in a while, these properties they'll remove their historical crop designation, and they'll call them non-crop. And the way so then you look at that and you're like, well, geez, it looks like it's got maybe crop, some old field edges or something, but it says it's non-crop. What's going on here? Well, it's because it's likely forever going to be non-crop because of some kind of easement or something. So that's where our relationship with all of our partners have been, across the board. All the agencies have fed us as much data as they can on their own land use history records, and we plugged all that in to refine the data set. So that's kind of what CLU does for us. The other kind of 800-pound gorilla in the analysis world is go-back pasture, or go-back grassland. Now these are lands that may have been tilled sometime 100 years ago, 70 years ago. Maybe they took advantage of the flax market in the 1940s for just a few years and then abandoned the field. So what are those? So they've likely, more than likely, if they were tilled years and years ago, they revegetated with some semblance of native vegetation. Sometimes they were actively planted back. But what's really the reality here is there's very little records of this. So unless we can absolutely prove that something has a cropping history, we leave it in our undisturbed grassland category, but we draw a polygon around it, we map it, and so that you can separate it out if needed. And that's, I'll get into that a little bit. So we do treat go-back pasture slightly differently, and we track it. The indicators, like I said, these fields can be very old, rock piles. Maybe it's a favorite area, maybe it's a level area in an otherwise native ranch that they've always hayed. That's a pretty good indicator that it could be go-back fields. Or maybe there's an old foundation or windmill or something to help us, give us some clues that it's likely a go-back field. And then we'll map it accordingly. Okay, that's the quick and dirty on methods. Is there any question on any of that? Makes sense, I hope. Okay, so as far as results, we've worked on the project in 4 different phases, actually 5. Phase 1 was the Prairie Coteau region of eastern South Dakota. Phase 2, we did the Prairie Coteau region of western Minnesota. I'm not going to present any results from Minnesota today. Just understand that Minnesota is worse than South Dakota. And I'm from Minnesota, so I can say that. Yeah, we've got very little grassland left in that part of Minnesota. Phase 3 was the Missouri Coteau region of eastern South Dakota. And then phase 4 was what's yellow, all the fill-in areas, and revisiting phases 1 and 3 to refine the data from those. As we got more information in, we were able to go back and kind of clean up phases 1 and 3. And then finally, phase 5 is western South Dakota, and we'll cover that here in a little bit. This is kind of the shock and awe photo. This is what we call the negative. This is the cumulative cropping history of eastern South Dakota and southwest Minnesota based on our analysis. Doesn't mean that all of that is black dirt today by any means, but it means that all of that had at one time been tilled or disturbed for agricultural or other reasons. Okay, so that's what it looks like. That's kind of a downer. So we'll try to move away from that a little bit. This is what we can offer in regard to the results of the products from our work. We've got the information both in geodatabase and shapefiles. We've got the reports, the charts, and the maps. All of that is available to all of you. So everything you guys are going to see from the rest of the presentation is publicly available. I've got it posted on the SDSU box site. We've got a link to it, but we really want to make sure that this data is out there and usable, and that's why I wanted to present here today. So if you're a graduate student and you're working on any kind of habitat project, you might want to take a look at this if you're interested in the distribution of native habitats in the east. Okay, so what do the stats tell us? We have just 22.6 million acres I guess I don't have a pointer, so I'm not going to use my hand. 22.6 million acres of total land in eastern South Dakota. Of that, almost 15 million acres got thrown out immediately because it had a cropping history. And then we identified about 1.5 million acres of other disturbance, for a grand total of about 16.5 million acres of disturbed land. And then there's about 670,000 under water bodies that are greater than 40 acres. So all told, 72.8% of eastern South Dakota has a disturbance history. Lower or higher than you anticipated, I don't know, but it's interesting because we can finally put some numbers on it. So the other 5,488,025 acres we think likely are undisturbed or potentially native, representing about 24%. This isn't necessarily bad in relation to where other states are in the Midwest. Primarily, this is our northern, the part of this landscape that's northern tallgrass prairie. We're probably a little better off than Iowa, Minnesota, etc., which our northern tallgrass region is kind of through this region. But all in all, 24%. I was surprised. I thought it'd be lower than that. I'm not really happy about that number, but I thought it would be lower. Of that 5.5 million undisturbed or potentially native acres, what the breakdown looks like is that 97% of that, 98% is grass, and about 2% or so is woodlands. That shouldn't surprise really any of us living in eastern South Dakota. So that's kind of the breakdown of the native habitats. We also did an analysis of, well, what's the status of those acres? If they're native, are they protected? Will they be here 5, 10, 15 years from now? So we looked at analyzing the protection status. The protection status had to be something that was going to be perpetual. That was what we rolled into our protected lands analysis. So of that, the entirety of the 22.6 million acres in eastern South Dakota, only about 1.3 million are protected, which represents about 6% of eastern South Dakota. Okay, protected. That doesn't mean that they're native. That just means that that's kind of the cumulative protected acres. If we look at what's both native and protected, the number gets quite a bit smaller. Native and protected, we don't even have 1 million acres. So the native and protected represents about 17.5% of all of the undisturbed land. Okay, does that make sense? About 17 out of 100 acres of undisturbed land is protected. But the interesting thing is almost 70% of the protected acres are actually native or undisturbed based on our analysis. So what the take-home message on that statistic is that even though we don't have nearly enough protection out there of these native grasslands, the acres that are getting protected more or less are native acres. So when the U.S. Fish and Wildlife Service works with the producer with an easement on their property, 7 of those 10 acres are native. That's pretty good. I think that's pretty good program focus. Overall, undisturbed and protected, 4.3% of eastern South Dakota land. That's what it looks like in pie chart form. Pretty small sliver of the overall landscape that we can say, without a doubt, will be there in the future. The green represents everything that's disturbed or native. The dark green is what portion of that is actually under some type of protection. So we've got a long way to go. The key is making this green pie shape bigger and stopping this one from getting smaller as far as overall grassland protection and management. So within our reports, we broke this down a million different ways, and for the user, and we hope it's really valuable. We wanted to know, we were curious, so these are just kind of a sampling of some of the tables that you can find in our reports and our data analysis. But for instance, what county has the greatest amount of native or potentially native sod? McPherson County. It's also a very large county. As far as overall percent of grassland cover is Buffalo County. Not a big surprise. Crow Creek Reservation land is a lot of that. As far as the big losers, you know, again, maybe not too much of a surprise. You know, once you get down in that southeast area, you're not going to find a lot of habitat. But Clay County, both the lowest total amount of native and the lowest percentage in eastern South Dakota. And you can see, again, should be no surprise, but when you see it finally kind of visually, it's like, well, the drainages. The steep stuff is where the grass still exists. Other than that, it's pretty much been converted for ag or other uses. When we do a look at the woodland analysis, the total, you know, the highest total acres of woodlands was Roberts County in extreme northeast South Dakota on the escarpment of the Prairie Coteau. But as far as percentage of woodland cover is Charles Mix and Union counties. Did I skip Union? Anyway, this is Charles Mix. Charles Mix has got a high number of total acres. I'm sorry, yeah. Charles Mix and Roberts County had a high number of total acres comparatively, and Union County had the highest percentage. So while there's hardly any acres of native or undisturbed land in Union County, because of the Big Sioux River and the Missouri River, most of what's there that you would, you know, categorize as native habitats is the woodlands along with the rivers. So hopefully that's useful for folks. Now we look at protection of those grasslands. Again, McPherson County has the greatest total amount of protected acres. Falk County, which is on the screen right now, has the highest percentage. So of all the undisturbed acres in Falk County, 47.7% are protected. Not bad, comparatively. And you see that, remember when I said Buffalo County had the most total percentage of native grass, but it falls way down on the protected chart. Most of that is reservation land, and there's no legal necessarily protection. Now, is it eminently threatened? Probably not, given that most of it's tribal, but it's not legally protected. And I wanted to make sure that we understand that distinction, because that's going to be important going forward here. I mentioned the go-back land. So that was kind of an evolving analysis as we were going through this process. We didn't really assess it very much on the Prairie Coteau. We didn't think it was going to be that big of a player. As we started to realize that we needed to start tracking go-back land, we initiated an analysis on the Missouri Coteau, and that about 2% of the stuff that we identified as undisturbed or potentially native had a go-back designation, just not sure. And then Ben and Tanner worked to even refine that a little further, the process through the remainder of eastern South Dakota. And there, this ground is hovering at about 7.5% of what we identified as undisturbed grassland. Might be go-back, might have a tillage history, but we're just not sure. We just don't have, we've got some, you'll see here later in the presentation, some ways that we can potentially address that and figure that out, but we don't have the time or the resources right now to take a look at those 7%. So that's just full disclosure. Where we do map go-back acres though, the guys do a very good job of looking for edges. And so these are, all of the mapping that we're doing is I would say precision mapping, all right? It's not just going into a section and blobbing out, you know, oh, we think there's go-back here, so we're gonna drop 40 acres square. No, it looks like this. So if you're utilizing our data, even at the smallest scale, the edge that you're utilizing will have a reason for being there. It's not just an estimated edge. It's an edge that's informed by something. Whether it's correct or not, it's not estimated. It's actually measured and mapped. Okay, does that make sense to everyone? So that's where we think the power of the go-back mapping really comes in. Okay, well, not everything is based on counties. Not everything is based on political boundaries. So we also just wanted to show you, the ability to take our data and use it with any other NOAA data. So here we overlaid the Class 4 EPA ecoregions. 23 of them intersect eastern South Dakota. And you can see now by ecoregional analysis, obviously, let's see, 18 here is the Missouri Coteau. You can see the pretty sharp cutoffs for the density of grass on those ecoregional lines. The eastern escarpment of the Prairie Coteau over here, and the western escarpment over here, they show up pretty well. Along the Missouri River, obviously, on the southern Missouri River breaks, ecoregion. So ecoregional analysis, especially for conservation planning purposes, might be one potential tool, or any other number of polygons that you want to apply. You can also overlay the protected data on top of that if you wanted to analyze protection and undisturbed land and protection status by ecoregion. Interestingly, on the ecoregional analysis, who would have thought the James River lowland would have the most potentially native grassland in eastern South Dakota? But it's a scale thing. It's huge. It's the biggest ecoregion out there. So at just over 1 million acres of native sod, well, it's almost got 6 million acre ecoregion. So percentages are probably the better way to look at those ecoregional comparisons. And with the percentages, the northern Missouri River breaks, comes out on top. That the density of the grasslands right in that area in eastern South Dakota, again, Buffalo County area, Crow Creek Reservation area. This is the James River lowland. So you can see, but surprisingly, I always thought of Huron as almost having no grasslands around it. Surprisingly, there's still stuff that's left worth fighting for over there. As far as the grassland analysis, again, the James River lowland, Woodlands, has the highest total acres of woodlands, but not nearly the highest percentage. There's just not that much woodland in the James River lowland. But where we do see a high degree of woodlands is across the, down to the southern Missouri on the Woodland Plain. A lot of cedar in that country, a lot of some native hardwoods, but. So that's the type of analysis that we think, that makes our data really useful. Okay, so that's kind of the rundown of what we found. The big question is, when you look at these two maps, I don't know if I can back up here. This is what you get if you did not do anything but apply the common land unit data to the landscape. That's what this map on the right looks like. This is what you get after what we did. After you go through the process of what we did. So is it worth it? Is all this work worth it? And the reality is, I think so. Because what it does is it refines that landscape at the level that we actually do research, monitoring, and assessments. And let me just show you an example here. If you were going to do the common land unit data only, see this right here? This would show up as non-crop. Anybody know what that is? Sioux Falls, Harrisburg, that whole region. Here that's thrown out. That's a stark example. But if you look deeper into this, into these, there's a lot of white that disappears here, but it's really difficult to see. So what we wanted to do is try to figure out, well, how can we assess our effort? Did we learn enough to be able to justify the work? And so what we did on a county by county basis is we did this, it's kind of what we call a refinement measure. How much more did we learn about that county by doing what we did? And in the counties where there was a lot of crop ground and a lot of other disturbances, we learned quite a bit more. So as an example, in Lincoln County, if you took out if you just cut all of the common land unit data out, initially, let's say Lincoln County's 200 acres, right? And the common land unit data says 100 acres is cropland. So then you would say, okay, we got 100 acres left. What we found then, of that 100 acres, another 60 is disturbed, okay? So that's the Lincoln County example. Down in Hyde County, we found, well, I just clicked it, I can't go back. In Hyde County, it was 1 in 10, okay? So every 10 acres that would have been left after that initial cropland cut, we would find one more that had a disturbance history. I think that's actually worth it. I think that even at the very minimum, on average across eastern South Dakota, we refined the landscape by 40% on average. So some counties were, the lowest was 10, the highest was 60. Management implications, we're still losing native grasslands. This is still occurring today in pockets all across eastern South Dakota. And at some point we have to quantify where we're at if we're going to measure loss going forward. The sad thing about everything I'm talking about is the number will never get bigger. It can't. It cannot get bigger. It can only get smaller. So we can only start to measure the loss, and that's kind of the tragedy of what of all of this information. But it's still happening. 2012, 2013, Burley County, sprayed out and then scalped in with corn. This is even after crop prices started dropping. And this is, it's kind of a personal aside, but I think there's only 2 ways you can make more money on corn. You got to plant it more, you got to plant it denser to make more yield. You got to use precision farming to create more yield within the field, or you got to find more acres. And people are continually still trying to find more acres. Kind of makes you wish we had this again. As far as what our data can do for informed policy, just got a couple examples. Had we had this layer a couple years ago when we developed the Grasslands CRP program, it might have helped shape the conversation as to where those program priorities should fall. Not sure if it would have, but it might have. And I think that's kind of an analogy for all programs going forward, whether they're EQIP programs, WIP programs, whatever it might be. Our layers should help inform priorities. The other thing is that this is kind of just a rough map that Ben produced, but you could actually take our data and create kind of the native sod thunderstorm map. Where are the highest densities occurring within each county or within each kind of geography, and look at it that way as far as a way to shape conservation programs. When applied directly to the Fish and Wildlife Service's thunderstorm mapping for waterfowl and breeding pairs, what this is an overlay of both our data on a traditional thunderstorm map, and everything in the dark or maroonish brownish color is where they line up, where we have identified their acres as potentially undisturbed or native. Everything that's pink are acres that are not necessarily native, that they were identified as grassland, and we said, yes, it's grassland, but it's not native grassland. Is that important for a duck? Not always. But is it important to understand the dynamic of the landscape that the duck is in? Maybe. So that's where, that may be important. Okay, so the other kind of thing that we stumbled on is policy on state and federal lands. When we started this project, we had this kind of grand assumption that state land that was owned by the state should probably go under our protection category. After conversations with Game Fish and Parks and School of Public Lands, it's not actually the case. State school and public lands are not truly protected from conversion right now. There's a moratorium on it, but it's kind of an internal commissioner policy. And the hard question I asked the commissioner was, if you wanted to tomorrow come in and pen a new resolution that you're going to convert state school and public lands to cropland use, could you do it? Do you have the authority? He said, well, yeah, I actually do have that authority. So technically they're not protected. Same with game fish and parks. It was a surprise to me to find that. Now, I'm not saying these things happen or that they're eminently threatening, but a game fish and parks habitat manager could actually go out and turn over 50 acres of sod if they wanted to put in a food plot. They might get chastised for it, they might get fired for it, but it's not actually, there's nothing in statute that says they can't do it. So it's important, and so then just by this work alone has raised some of those questions in those agencies as to what their own internal policies are. Do they value the native sod, and are they actually reflecting that? The example here for eastern South Dakota is right in that corner of Potter County. The red is a highlight of state school and public lands in that part of the county. And if you look at Potter County, right now there's, you can see it's about 166,000 acres of undisturbed or potentially native grassland. 20,000 of that is protected, okay? If you threw in and actually had state school and public lands protected, and game fish and parks lands protected, we would double the protection status of the acres in Potter County. So it's kind of, it's an important thing to consider. And when I was talking with the Commissioner of School and Public Lands, he gets it. He's like, wow, in some counties, we may represent a significant portion of native grassland acres, and if we don't have, if our acres aren't there, are there any grasslands left in that county? And I said, no, that's why I'm bringing it. I brought it to his attention. So, well, I don't know if it'll change anything, but at least they're aware. Okay, that's eastern South Dakota. Any questions on the east? Any of those points or anything? Okay. We'll go on to the west then here. Just kind of give you a taste for what we're doing in the west. We've only done 4 counties. This is just rough data. This is not final data. It hasn't been refined yet. But basically, we've got about 1.5 million disturbed acres in the west out of a 7.2 million acre landscape. About 21% is disturbed. So just using those 4 counties as an example, about the complete opposite of what we saw in eastern South Dakota. Now this doesn't represent all of the west, but it's just kind of interesting. About 5.6 million acres are undisturbed, so 78% or so. No surprise there really. We would have assumed that the majority of western South Dakota was likely, or that northwest corner was likely undisturbed. And that's why we started there. The Nature Conservancy funded that portion. They wanted to utilize that with their conservation planning efforts. As far as protected though, it's a much different story. There really isn't any, there's a lot of agency-owned land out there, so it's not necessarily that it's eminently it's not eminently threatened with conversion, but it's also really not actually protected from conversion either. So there's only about 10,000 acres that we identified as actually legally protected from conversion in the northwest corner of the state, which kind of is surprising. And we've got BLM and Forest Service and BIA and some Bureau of Rec, tribal, Park Service, other ownerships out there. So there's a hodgepodge of federal ownership out there, but so again, I'm not sure that it's necessarily eminently threatened, but it may not also be protected. The go-back story out there is just a little bit different, and we ended up having yet another category that we had to really recognize in western South Dakota. There is the true go-back acres, the land that was tilled for farming purposes, created hay fields or whatever, that may not have much of a record. Those are true go-back fields. The other thing that we stumbled upon was Sandy's, any other reading, Flora, Sandy, whatever, rangeland employees, rangeland scientists. These are hard pans, western South Dakota hard pans. And I had no idea of the scope and extent of rangeland manipulation on this type of thing. And it's really interesting. So this started, it's got a kind of an up and down history, but I'm just showing some different photos of equipment. These were compiled by Rod Baumberger in order to try to break up those hard pans, get water infiltration, and increase production on some of those native rangelands. All things that might go against the current philosophy of soil health. So it's really an interesting dynamic. So that was the circa the 20s, then you had kind of circa the 50s, things started to get a little bit more aggressive. 60s, 70s, now we're getting into the 4-wheel drive era. And this is what could be the result of that rangeland manipulation. So we started looking at this and we're like, well, crap, what is this? It isn't for farming, it's never intended to grow a crop, but it surely isn't native sod anymore in the purest sense of the word. And we had this iron in the ground kind of benchmark, and we really struggled with what to do with these lands, because ultimately they kind of look like this in the end when they revegetate. There's plenty of data that shows that they actually did increase forage production, but they also a lot of times went in and planted non-natives, broadcasted clovers, tribal alfalfa, whatever it might be, crested wheat. That's a hodgepodge, and so you really can't call them, like I said, in the pure sense of the word, native grasslands. But yet, they're not necessarily go-back fields either, so we just call them what they are. We categorize them as rangeland improvement projects, because this is what they look like aerially. You see these areas, and Tanner was the one that first kind of started to see these patterns. We really didn't know what they were. But sometimes they can be very heavy, and sometimes they can be very light. You can see that this is actually just a 2-track vehicle trail across the pasture. So the imagery that we're getting from the satellites is just getting that much better. I'm not sure we would have saw this with first generation or second generation imagery, but we should sure see it today. And again, sometimes you can even see the cattle trails going across it. So the pattern that we're seeing is actually the vegetation pattern, maybe more so even than the pattern of the soil. So again, we're flagging it, we're categorizing it. We're not really sure what it means.
Say, Pete, are you going to get records from NRCS to help you identify those, or are you just going to just do it visually like this?
We have to do it basically like this because what's so sad and it's just so frustrating, so many of those offices have purged their records. Like the 7-year rule, I talked to several range scientists out there. There's very few people, Ryan Beard from McIntosh with NRCS, he knows that they're in their district. They don't do anything. They don't go back and look at them. So this is a side note, but at some point this fall, I'd like to have like an open invitation to anybody that is interested to go do a tour and just walk around all these things and see what they really are today as far as plant community. What I think is common sense, and I don't have any proof, is that if in fact there's sensitive species that were manipulated with that mechanical manipulation, we probably lost something in those native systems, whether it's soil microbes, whether it's diversity underground, whatever it might be. I don't really know, but I think common sense would say that it probably can't be what it was when you take that level of manipulation.
I think the only thing that would be is if they introduce some species, non-native, because most of the data that Bob Gardner, I mean, this was part of his extension career, was going out and doing this. And I've been on Bill Slavic's ranch where, some of that was done. So if they put in a legume or they put in like a crested wheatgrass or something, then I think you're correct, it would have changed. But most of the times they didn't do anything, and it just filled in with western wheatgrass, and the blue ground and buffalo grass decreased.
But do you think that you
And
lost?
then the hills and the valleys over time mellow out, but you can still see a little bit. But in the state transition model, they put it in separate category.
What about the more sensitive fork type species that may not have ever recovered? Because I didn't see a lot of data that, I don't even know if that stuff was there because it's these hard pans.
Yeah, I don't think it'd be a good matter.
So I don't know, it's a really interesting quantity. So what we're doing, I guess the take home is that we're doing our best to track that. Historical records, maybe you get at it county by county, but we need to have some conversations with both BIA, BLM, and NRCS, because it occurs across all those lands, and some Forest Service lands. And the record keeping is.
Because, if you could get with Bob Gardner, you can find out where he did some of this stuff, and that could be an interesting side project, just to compare floristic quality on,
Rod
on those
Baumberger.
areas and areas without them.
So I should say that on our box account, we also digitized all of Rod Baumberger's old records, because they did go back and do some read-and-out, and you can't argue with the data. They improved production for several years, and then it died off. I'm just not sure that if it's something about it just seems a little bit too intensive for good range management, but that's my opinion. Okay, so going forward, and this kind of gets to the paper that I handed out earlier, what we would like to see come from this effort, this analysis, which is, I'd love to see SDSU be able to, in any number of arenas, work on utilizing this data for the greater good. One thing is adoption by other states. We have the Farm Service Agency data, this common land unit data to be able to do that. I'm not sure we have the horsepower to be able to do other states. It takes, it's going to take us about 2 years to do South Dakota. In the long run, not all that expensive, about $350,000 or so. But can we entice other states? Is there enough value to this process to entice other states to get a true, accurate, more accurate count of their native rangeland? And then with that, what about the information repository? How do we handle that information if it does start to get compiled? Because even with our stuff, what I'm going to show you going forward is it's always going to be able to be refined. There's always going to be the next person that's going to take a closer look at what we did. Maybe they'll get out there, boots on the ground, and say, hey, I actually found field images and things like that. To be able to continually categorize the native historic imagery refinement. We gotta be done?
Yeah.
Okay. So it's on that list, I'll just click through these, you know, we got historic imagery, that can be applied. LiDAR data really, when we played around with LiDAR, it really helps. We're still getting conversion, obviously the habitat quality assessments, Cedar. Michelle Bouchard and Mike Wimberly have worked on some spatial analysis, so a lot to be done there. But there's a lot that we can do with this. And if you've got any interest in exploring where this data can go, please let me know. I'm sorry, I thought I was looking at 11 o'clock, so probably no time for questions.
Maybe one really fast one.
Pete, I think it would be cool if we could get this up on the web soil survey, that could be a data layer for South Dakota. Because then when you do the vegetation productivity, at least your layer could potentially be the native component. Because other times you have no idea what it is.
Yeah.
So I think if you could get it up on web soil survey and work with NRCS to adopt your layer, that might help other states adopt this as well because they really see the value of it.
And I should, in full disclosure, we really kind of made this methodology up as we've gone. Actually, very tight. We got a lot of good advice from smart people. So we're in the process, Sandy's review, we're publishing the report through SDSU, but I do need to get a methods paper published in a journal here real shortly so that it's citable and replicable and those types of things. That step in the process hasn't really happened. Those of you that are going to join us for the technical session.
Yes, so Pete and his team have offered to do a demo of the data layers, and we will reconvene in probably about 11:15 in Wecoda 6. Okay, that's the basement of Wecoda, and we already have the data layers and everything loaded up, ready to go.
Oh, great.
Okay.
Wecoda 6 basement.
Basement, yep. Thank you, everyone.